everyone, I am Agrita Fesilia Takawaian with my ID 110110501. My class is semester 8, 2021. I am student of Sam Ratulangi University. In this video, I will briefly discuss dispersion system material. Enjoy watching! What is dispersion system? Dispersion system are systems containing at least two phases, with one phase being dispersed in the other phase in the form of small particles. Basic classification. A dispersed phase is referred to as the dispersion ratio or dispersion phase. The phase whose continuity remains persevere is referred to as the dispersion environment. Dispersion system may be classified using several criteria. Size of matter of the dispersion environment and the dispersion phase, size of particle of the dispersion phase, structure of the dispersion phase. Classification based on the phase stage of matter is summarized in the following table. Based on the particle size, dispersion systems are classified as analytical dispersions with the particle size less than 5 nm, colloid dispersion with the particle size ranging from 5 to 100 nm, microdispersions with the particle size ranging from 100 nm to 10 micrometer, coarse dispersions with the particle size over 10 micrometer. Note: analytical dispersion systems rank rather among homogeneous systems. Microdispersion and coarse dispersions are usually ranked among suspension. Based on the dispersed ratio structure, dispersion system may be classified as system with isolated, often roughly spherical, particles called sols, system with an interlinked structure of the dispersion phase forming a next structure in the dispersion environment, which are called gels. The name given to individual dispersion systems often combine the particle shape and the phase of dispersion environment. Solids with air as the dispersion environment are referred to as aerosols, while those with liquid as the dispersion environment are called lyosols. Lyos equals liquid. Properties of colloid system. Systems containing colloid particles are in some properties different from systems which are homogeneous or composed of macroscopic phases. Light scattering. If light passes through a system containing colloid particles, part of the light is scattered and consequently the ray passage through the environment can be observed, the Tyndall effect. For the intensity I of light passing through and dispersion environment, we write compare with relation, where L is the length of the dispersion environment through which the light passes, optic path. Torch is the turbidity coefficient. I0 is the intensity of the initial light. A decrease in the light intensity in the original direction is not due to the absorption of light by the molecule of the substance, but is caused by its scattering to all directions by reflection from the colloid particle. The initial wavelength of the light remains perceived during its scattering. For the total intensity of scattered light, I scat is I scat equals I0 minus I. The Rayleigh formula applies as follows, where n is the number of particles of the volume, few particles in unit volume. Lambda is the wavelength of the incident light. N0 is the refraction index, or the dispersion environment, and N1 is refraction index of the dispersion ratio. From this relation, it is obvious that in order for scattered light, the origin, the diffraction index of the dispersion ratio, and that of the dispersion environment have to be different. Light scattering is proportional to the number of particles in the system. The scattered light is proportional to the quadrant of the particle volume. The scattering is inversely proportional to the fourth power of the wavelength of the incident light. Example: explain why the sky is blue and the setting sun is red.
Why are sunsets red?
'Cause sunsets are romantic.
Nah. It is basically because of scattering of light in the atmosphere. Our atmosphere is primarily composed of tiny nitrogen and oxygen particles. Now usually, when sunlight comprising of 7 colors passes through the atmosphere, it hits the nitrogen and oxygen particles. These particles scatter blue and violet light more as compared to red, orange, and other colored lights. Hence, mostly bluish light enters our eyes, thus making the sky to usually appear blue. However, during sunset, the sunlight must pass through a greater distance in the Earth's atmosphere, causing it to pass through more particles. As a result, most of the blue and violet light gets scattered before they reach our eyes. Due to this, the less scattered light like red or orange reaches our eyes, making the sunset appear red.
Thank you for watching my video. God bless you.